The microphone is on today, everyone. Check, check. What? My microphone is on. Hurrah. So. Okay. All right. That's funny, Jaden. I don't see any notes on your paper on your desk. All right. So, no, I said I'm going to pass it out in a second. So, isolating the variable is what we did on Friday. No, it's just like this is a reminder example of what we did. That's what they look like. They're like 1- and 2-step equations. I actually think I'm just probably not going to teach this because I think it was not helpful and I don't think they're being tested on it. So we're moving on.
Right.
Yeah. So I'll send out a Canvas assignment later. Now, this one almost looks like an isolate the variable. However, we have an extra thing to keep track of. We have a tangent squared. Have we ever seen a tangent squared before? No, we have not. But, about to show you a magic trick. We do our U substitution, right? Where we turn our scary trig function into a U. So when we rewrite it, it'll be U squared plus U equals 2. So what if I subtracted the 2 and I have a U squared plus U minus 2 equals 0? Does that look like anything you've ever done before?
Yes.
Oh my gosh, it looks like factoring and drawing your boxes and drawing your X's. So I don't really want to draw my box for this one since we have an A value of 1. We're going to draw our box on the next one where our A value is 2. But whenever I work in the math lab, I tell them that there's 6 things you can write down first thing. 4 different parentheses, an equal sign, and a 0. Every time you know you're going to end up with that. You don't have an A value, so you have 2 regular U's, because it would be crazy if you had anything else. What adds to be 1 and multiplies to be negative 2? We don't have to do our box, but we'll draw our X. So I heard a what? 2 and negative 1. So now these are going to be what we plug in over here. So we'll have a plus 2 and a minus 1. So what do you do when you get to this step? You set them both equal to 0. So we got a U plus 2 equals 0 and a U minus 1 equals 0. And then we got a U equals a negative 2, a U equals 1. Now, do we remember from Friday that once we got U equal to something, that's where we get to put our tangent back in? That's okay. Tangent equal to negative 2, tangent equal to 1. Now, tangent comes from our ordered pairs. So we have a root 3 over 2 and tangent equals y over x. If I took all of my y values and put them over the x values, is there any possible way I could get a -2 out of that? No. You would never get a 1, or you'd never get a -2 from tangent. You could get a -2 from secant or cosecant, but not from tangent. So this is the best part. We get to ignore it. So now all we have left to deal with is this tan equals negative, or tan equals 1. Where does tangent equal 1? Well, yeah. So radian-wise, what is that? Pi force. And I don't know if anyone saw this up here, but it says solution 0 to 2 pi. So where else on our unit circle are we looking? Tangent is positive in what 2 quadrants? 1 and 3. All students take calc. So we're looking in quadrant 3. What's the value in quadrant 3 that will make this positive 1? And that's your answer. So you see how there was slightly more steps to get there, but it's kind of the same thing as what we were just doing.
Right.
We're doing more heavy lifting on the algebra than we are on the trig right now.
Okay, I'll take that.
So who liked algebra?
I was pretty good.
Okay. All right. So I'm hoping then this next one is going to be like your bread and butter. Is everyone cool if I move on? So we're going to focus on this one first thing. 2 sine squared theta minus 3 sine theta plus 1. Now, I could be nice and get rid of these thetas. However, the thetas aren't going away. It's a Greek letter that we use, and it's going to be all over. So, but we can get rid of our trig function, right? Right. What are we going to put there instead? Again, you could hypothetically put any letter you want, but use just, it's not used by anything else. So we have a 2u squared minus 3u plus 1 equals 0. Now I'm going to build your box with you so that I can let you fly free on the next one. Because an a value other than 1 almost sent 5th block packing back to algebra 2. We need a number that multiplies to 2 and adds to -3. What 2 numbers multiply to 2 and add to -3? Osmo? -2 and -1. So now this is the only thing we pull out of this x. That's all we need. We keep our 2u squared intact. We keep our plus 1 intact. And then we put a minus 2u and a minus 1u. Now, you can do your signs first or pull out your negatives. I'm going to start with this row. 2u squared minus 2u can pull out a what? A 2u. minus 1u plus 1, you can pull out a 1, but in terms of the sign, it's a negative sign touching the outside, so you got to put a negative. Now we're going on to our columns. 2u squared and minus 1u. What do we have in common? Just a u. Minus 2u plus 1. What can we put there? A 1. Is it a positive 1 or a negative 1? Negative. So when you come down here, you got a 2u minus 1, u minus 1 equals 0. Now I'm going to let you take the lead on this next part. If you separate them out, what two values are your u equal to? Say it in your head, and then I'm going to call on people.
Say it one more time.
Figure out what u equals. I really believe that now that we're here, you can figure out what u equals. David, can you give me one of the values that u equals? 1/2. Perfect. Natalie, what's my other value? 1. Yay! So now we're going to go back up, and we had a sign equal to u. So now that u is equal to a number, we're going to plug sign back in. So sine of theta equals 1/2. Sine of theta equals 1. So now you're going to have more than 2 answers since you have 2 things here. And most of the time you get 2 answers. So remember, Miss K is going to be very particular about the way that she accepts her notation. So my suggestion to you is underneath sine theta equals 1/2, write down the 2 values that sine equals 1/2 at. What are my 2 values? Radian values. I hear pi thirds. Do I hear anything else? I was going to say, I'm going to guess it's pi 6 and 5 pi 6. And where does sine equal 1? Pi over 2. So now if I rewrite this in the order that they appear, we get pi 6, pi halves, and 5 pi 6. I would count a point off if you write it like this. It has to be in the correct unit circle order. That should not be a difficult task, as you guys know the unit circle very well. So, is everyone cool on that one? Does everyone remember our factoring? Perfect. So we're going to come up here, and the only thing I'm going to do before I let you fly the nest is I'm going to subtract this 1, and we're going to get this equal to 0. You do the U sub. Woo! You do the U sub, and I also want you to build your box, build your railroad tracks, or whatever you call them, your big X. Whatever you need to do in order to factor this. And you don't have to find what u equals. I just need the factored form of this. I don't agree with your signs.
What are you talking about? This the old one. I haven't even started yet.
Okay. Well, that would be problematic. For a lot of people that said they liked algebra, this factoring does not seem to be treating you nicely.
Make sure. Okay, I was right. She said she would question.
Yeah.
What makes it negative?
So this top value is A times C.
Oh, okay.
This is A times C and this is B. So what multiplies to -2 and adds to 1?
You said 2 negative. Yeah.
So I'm going to put them in the boxes. I'm not going to do it. I believe in you. Jaden, what did you factor this for? The one that has his head down right now.
Huh?
How did you factor this? What did you get?
Oh no.
Do you want to phone a friend?
Yeah, sure.
Okay, I would suggest you put your head up. David, what'd you get? You know how you can check yourself too? I think I did this wrong in the last class. I most certainly did. No, because at least one of these should be negative. Yeah. Every day. Okay, so then everyone's favorite part. We split them up. We set them equal to 0. What is u equal? So now that we have u equal to something, we get to plug it back in. So I'm going to plug my cosine back in. Cos equals 1/2. Cos equals -1. Can cosine equal 1/2 or -1? Can it equal both? Yes. Perfect. Where on my unit circle does cosine equal 1/2? Did you have a comment for the class or a question? You were just going to answer. So then cosine equals -1. Where is that at? So can someone tell me, and by someone I mean the Jaden that has his head up, what order would you put it in? Yeah, when you put it in interval notation, what order would you put it in? There we go.
Why is this so funny? Oh my.
David always thinks everything is funny. I can't even lie.
Hey.
Okay.
He's just so silly, guys.
Is this making sense? We're going to practice this tomorrow. I told 5th block I might show up in camo tomorrow because we need some boot camp on factoring. Yeah, Anna.
So for when we're looking on the unit circle to see, because when we got to see if they're the cosine would work with 1/2 and -1, it doesn't matter what quadrant they fall in. It's just as long as it's cosine, the cosine is 1/2 or whatever. it is.
Yeah, so the quadrants only matter when there's a negative 1.
Okay.
-1 or arc sine, arc cos. So
So that doesn't matter in these problems.
no. So most of these problems, 2 ways you'll be able to tell. It has a -1, and this here will say 0 to 2 pi. So that means it needs the solutions. Okay. So, check. We did another one. Using the identities. Everyone be here with me.
Oh, no.
No. This is literally the unit circle. I'm so
I
serious.
mean, yeah, the X, Y,
X, Y, and R. What equation do we use using X, Y, and R? That's all you need to know.
Okay, wait, I need to write that.
If it's a triangle, it's
Yeah, why do I throw up a triangle there and you guys like revolt? We did already do this. Thank you, David. So, wait a minute. Wait a minute. Boom. No. On the unit circle, x is equal to what? Cosine or sine? Cosine. So you see how I literally copied and pasted these slides. Okay. So that's why our x is equal.
Yeah, can't write the X, Y, and R.
This is x, this is y, this is r. On the unit circle, that's what all of those things mean.
I recall.
It's literally just illustrative.
Okay, cool.
So this is going to be your best friend. Sine squared plus cosine squared equals 1. Who didn't pick up a pink paper? Who still needs one?
I need one.
And before you freak out, we're not going to do anything with it until I have to. You already got a pink paper. Okay. So, on your pink paper, on the side where it says trigonometric identities, do you see that side of the paper?
Yeah.
It says definition, reciprocal identities, quotient identities, right?
Yeah.
We know all of those things, actually. You guys have already committed them to memory.
Yeah, they do.
The next section down where it says Pythagorean identities. The only one for this test that you need to know, if you want to circle, star, or square, is the one that we see up here. Sine squared plus cosine squared equals 1. So then, you're going to go down to the next section where it says variations of the Pythagorean identities. And the first two, top-wise, not first two here. So where it says sine squared equals 1 minus cosine squared, you're going to star it. Cosine squared equals 1 minus sine squared, you're going to star it. I need you to understand that those things come from this. I hope that that's easy for you to see, but if not, we're going to demonstrate it right now. if I subtracted a cosine squared here from both sides, we're just rearranging the equation, we end up with a sine squared theta equals 1 minus cosine squared theta. And then if I tried this again, and I actually wanted to do this with sine, I would subtract my sine first, and what would we get? These things you will live and breathe by in the next unit. We are just, no. We need this now, but this, like, if you don't have this nailed down right now, the next unit is going to be horrifying because it's just variations on this theme.
I thought we were supposed to be locking in today.
Yeah, I thought so too. I really did. So, since no one wants to lock in, maybe you can just like maybe you guys just want to do this one by yourself. We can do that. Like, what are you still writing down?
How are you going like get the class?
It's more than just them. I was not, but give me a thumbs up when we're ready to move on. Okay, so I conveniently place this little sine squared plus cosine squared equals 1 right there. However, we don't see anything that looks easy to replace, right? Except you do. You see how there's two different trig functions here? That would be really hard to deal with two at once. You would have u's. If you wanted to substitute the other one, you'd have probably a v. You'd still have to equal them out somehow, and it gets confusing. But what can we do? Because we have something where there's a sine squared embedded in a cosine squared, right? We just literally talked about that. How can I make this sine squared plus cosine squared equal to 1 equal cosine squared? Subtract the sine. So the identity we're going to use for this one is cosine squared theta equals 1 minus sine squared theta. So once you figure out what identity is useful for you, another helpful hint, when deciding which one you're going to choose, do I move the one that's squared? Do I move the one that's linear? Try to make it so that all of your equation matches the trig function that is not squared. So I'm going to move ahead just 1 second so that you guys I can illustrate this. So for this one, we have a cosine and a sine again. Which one of these would I be choosing?
Sine squared theta equals 1 minus cosine.
Choose the one that's not squared.
Yeah.
So which one are you choosing? You want cosine. So for this next one, we're going to choose cosine. So when you just directly there, that's what you do. So now we literally have this great thing that we can just plug in. So we'll turn that into a 1 minus sine squared theta equals 2 sine theta plus 2.
So we just do that.
Yeah, because those things are equivalent. Cosine squared theta is equal to 1 minus sine squared.
Okay.
I'm not just willy-nilly putting anything wherever I want.
Scared there for a second.
Say it louder, Sanaya.
Got you.
I thought we were just doing what people
Right. Well, I know that it has to come from somewhere. I promise you that. So now my biggest piece of advice for all these problems, you can have numbers in front of your squared trig function, but I wouldn't make it negative. So if I were you, I would move all of these things over to the right side to make this right here positive. Does that make sense? I'm going to do it, but I'm just saying that's what I'm going to do.
I might not be, put some twist later. Put over there.
Now I have everything equal to 0, so what can I do next? You get to change it to u, so u equals sine. So you see how this one, every time that we introduce one of these things, we're just adding on to what we did the day before. We're adding on to the last thing that we did. So now that we utilize the identity, now we're just back to factoring again. So that's what it should be whenever you are solving these. It should never be that you're reinventing the wheel whenever you're doing these problems. These factoring things should just pop out at you. Okay. So we have our what adds to 2 and multiplies to 1. 1 and 1. The best part about multiplicities when it comes to trig functions, you see how they're both u plus 1? Doesn't matter to us. We don't care. Because they're the same thing. So because we're not graphing it, it doesn't necessarily matter to us. Multiplicities matter whenever you're drawing a quadratic to see, zeros and stuff like that. To us, it doesn't really matter. So it's u equals that. This turns into u equals minus 1. So we sub our sine back in. Sine equals negative 1. Where does sine equal negative 1? Remember, we are not using our restricted domain because we never had an inverse. How are we feeling?
Honestly, I feel good.
Okay.
I feel good. If we do it again.
It's like
Yeah.
it's like a lot. It's a lot of stuff in.
But it's stuff we already know.
Exactly. Exactly. We're, like I said, we're doing a lot more heavy lifting on the algebra than we are on the trig.
Because I feel like we're doing algebra, but we're just using like words.
That's crazy. Okay, last one. Kind of cooked, can't even lie. So we already decided that we're going to use cosine. So how do we make this little equation over here look like a cosine? You minus the sine. So the new thing that we're going to use is cosine squared equals 1 minus sine squared. Now, can I have all eyes?
Wait, can we have a second to write that?
Yeah.
Wait, which side are you trying to find?
So we decided that we're going to be looking at the linear term. So cosine is not squared, so it's the linear term. Sine is squared. So we want to change our non-linear term into something that looks like our linear term. So because we currently have mismatched trig functions, we have a cosine and we have a sine.
Try to take cosine.
That's where we try to turn the sine into a cosine. So that's why we chose to do this. Oh wait, I think I see your confusion. I subtracted the wrong thing. Yeah, it should be cosine equal. No, it should be sine equal.
Wait, so,
Why are you wishing on?
I was just about to say, I thought we were moving the one that was squared.
Yeah, you keep the one that's currently in your equation on the side by itself.
So it doesn't change. It does change.
But you're going to plug it in. You're going to plug this in.
Bless you.
You're going to plug this in over here. So this is what I need all eyes for. The last one, we did not have a number in front of our squared term. If there is a squared, or if there is a number in front of your squared term, you must keep it outside of the parentheses and don't lose it because it doesn't go anywhere. We haven't changed the left side of this equation, so don't touch it. We didn't do anything with the 2. That has nothing to do with our equation, but we sub in what we just decided that we were going to sub in. Yeah, David.
So basically, I understand the thing that's not, the one that's not squared, you're trying to solve this.
Yeah, you want this one that's not squared. You want at the end of the day all of your trig functions to look like that. So now, first step you do in PEMDAS, parentheses, got to get rid of them. 3 cosine theta plus 3 equals 2 minus 2 cosine squared theta. Now again, my recommendation stands. I would recommend making your squared term positive. So instead of moving everything from the left to the right, I want to move everything from the right to the left. So I'm going to add my 2 cosine. Ta-da.
Still right.
I agree with you, CJ. He said this is where you change the cosine to a u.
You said what, CJ? I was like, AC, right? 2, 3. Oh, my bad. I'm wrong. It's 2. It's 2. I was the wrong one.
Thumbs up when you're done factoring. Then what are you doing? I didn't mess up, right?
Oh,
I have it. Yeah.
and the C goes at the bottom.
Yep. No, B.
B goes.
You already multiplied the A and the C out. Yeah. Oh my God, you guys. Factoring machines. So, once you built your box, or if you didn't build your box, or however you did it, did you end up with something that looks like this for your factored notation?
Wait, one to one. Huh? One. Yeah.
So then when we separate out our U's,
I ain't good box. Gotta set the box. Gotta set the box.
You don't set the box, you gotta get.
I got it.
you end up with a U equals... Why are we in such a rush?
Wait,
I know we have one more minute. So at the end of the day, what is my answers?
2 pi over 3. Or pi over 3.
And pi. Hurrah! Okay, that's all for the content for this unit. So now we just practice.
What about the exit ticket? Can you do that?
Oh yeah, if you guys can do the exit ticket.
I'll bring it back.
I mean, as long as you say something about